We are going to do site-to-site VPN. R1 is one site, R2 is another site, and we got this basic configuration. Uh, see, this basic configuration has got IP address on the loopback interface of R5 with OSPF. Why do I need OSPF? Because I need to provide reachability between R1 and R2. So we are going to run OSPF end to end. If you don't have reachability, then you cannot have VPN. So though it is not a OSPF topic, we need OSPF. That's why I have it, just to provide reachability. And next, if you see here on G03/0, I have 51001, as it is mentioned here. So 52001 with a mask of 30. That's why I put 52. And then I run OSPF here. So in the real world, the providers will not be mixing this network with the internal network. We are not going to do MPLS now, so it is okay. All that we want is a ping between R5 and R1 in order to have VPN. Though we have gone to an extent that realistic, but it is not 100% realistic. See, if it is 100% realistic, NATIC will come into picture here, and then here MPLS VPN tunnel will be there. Let's not get involved. We are trying to understand site-to-site VPN. So I'll call this as a basic configuration. This is R5's configuration with OSPF, and F00, which is inside interface of this ISP. And I have .5 here, and the mask is 16. OSPF is running. I'm going to paste this on R5, router 5. Now earlier I have configured R2. Let me show you the R2's configuration, which I did. This was R2's configuration. No, not this one. Show run on R2. Show run. And if you see here, I have given an IP address 52002 on G1/0 of R2. And then I have a loopback interface with this. Now, and if you notice that I'm not running OSPF on loopback, but I want to run OSPF on G1/0 so that I will have reachability. Here I would like to add OSPF on this interface. But I'm not running OSPF on the loopback interface. The reason is I'm going to encrypt the packet that is going between the loopbacks, between R1 loopback and R2 loopback. So the inner layer is going to be encrypted by a protocol called ESP. So there is no need for advertising 10.12 to the ISP. You don't need to advertise. I'll show you how to do this, but let me first of all go to this interface and go OSPF. IPSPF1 AS. The default mode of site-to-site VPN is tunnel mode. Because I'm doing tunnel mode, I have not advertised 10.12 network on R2. Because we are going to have two layers of layer 3, one with the original source and destination, the other one will with the tunnel source and destination. The original source and destination is going to be encrypted by encapsulation security payload, ESP. So what site-to-site VPN I'm doing is default site-to-site. Not a big difference between these two, but of course this is the difference which I already explained to you. The big difference is the header. You have two different header in transport mode. Sorry, in the tunnel mode, two different headers. In the transport mode, same header. We'll discuss on those differences after we finish this lab. First, let us do the site-to-site VPN, which most of the people need. 99% people will do only tunnel mode, which we are doing now. Transport mode is only between host to host, not between network to network. So what we are doing is for the popular one, the default one as well. Now, between R5 and R2, we already found a neighbor. Let's also quickly finish the basic configuration on R4, 3, and R1. On R4, I'm going to put the loopback as 4, and F00 will be 1034, 0.4, and the mask is 16. And F01, 45.4, the mask is 16. This I'll paste in a mark. Next is R3. On R3, this is the loopback. On F00, it's going to be 3 here. And G3/0, it's going to be 13.0.2. The mask is /30. Done. This will go on router 3. G3 is there, no? Router 3, you see? Okay. Now you see, we got the neighbor. We got the neighbor with router 4. Now, one last router, which is R1. On R1, the loopback is going to be, I think I finished R1. Let me check. R1, did I finish? Yeah, we already finished. And I would like to check whether I have OSPF here. Show IP OSPF interface brief. No OSPF. Let's put OSPF. I'm going to put OSPF only on G1/0. IP OSPF 1. Area C. See, for the tunnel mode, I no need to run OSPF on the loopbacks. See, what will happen if I run OSPF on my loopback of R1 and R2? My internal network will be advertised to ISP. Will you like it? No. No one will like it. No one will like it. That's why we don't go much with transparent transparent mode. The tunnel mode is what we do because we do not want to reveal our inside network. We want to go inside the tunnel. So we will have two separate layer 3 header with different source and destination. The original source and original destination is different from tunnel source and tunnel destination. What is the original source and original destination? 10.12.1.1, which is on router 1, is going to be the tunnel source. Traffic source. Traffic is going between 10.12.0.1 to 10.12. Sorry, not 0.1 slash 24, and it is going to remote local area network LAN, which is 2.1. This is the tunnel source and destination. In our case, it is, but it can be a computer behind R1. This is tunnel source and destination. Sorry, the data traffic source and destination. Tunnel source and destination is different. That will be another layer. Which is going to be 13. And right, this is the tunnel source and destination. This is what we call it as tunnel mode, the default mode. Whereas the transport mode, both tunnel and destination will be this. Both tunnel and traffic source. Both, if tunnel source and traffic source is same, then you need to go to transport mode, because you don't need two header. What am I doing? You don't need two header. Slider. Because the tunnel source and the traffic source is same, you don't need two different header. You can make use of the same header. That is what transport mode. But here we have tunnel separate source. The original traffic source is different. This will be totally encrypted. If you sniff packet in the ISP, you will see this one as ESP, encrypted. You will not find the layer 3 to 7. This layer 3 will be visible for you. This layer 3 will not be visible because it's encrypted. So no one in the ISP will know from where the packet is originally coming. According to the ISP guys, the packet is coming from 13001 going to 52002. But originally it is not that. This is tunnel mode. Whereas transport mode, when someone sniff in the middle, they know the layer 3 from where it is coming. But they will not know the data because layer 4 and above is going to be encrypted in the transport mode. Whereas in the tunnel mode, right from layer 3 itself, it is encrypted. But which layer 3? Traffic layer 3 header. Tunnel layer 3 header will be visible for routing purpose. So the packet can go from here to 52002. Is it clear? All right, now let us do this. I'm on R1. Let me check the reachability between R1 and R5 first. Sorry, R2. Ping 52.0.0.2. This is the address to which we are forming tunnel. When I ping, the source address is going to be 13001, which is also a tunnel source. So if I'm getting reply, R2 can reach 13001 and R1 can reach 52002. Between these two only we are going to form tunnel. Reachability is there. Now the platform is ready for us to start our configuration. Let's do the phase 1. Crypto ISAKMP policy. Now you need to give some number. Now, smaller the number, more preference is given when the policy need to be read. The router will read the policy with the small number first. If it is not matching with the neighbor, then it will read the second policy, match with the neighbor. See, the policy number need not to match with the neighbor. Here, policy can be 10. That said, policy can be 100. That doesn't matter. Inside, whatever we define should match. Here, policy 10 inside matters may match with policy 100 there inside. It is okay. Policy number is locally significant. When we have multiple policies, you may have many tunnels. With each remote neighbor, you have different policy. Then you need different policy, different IPSec can be policy with different numbers like 10, 20, 30, something like that. That's why we have numbers between 1 to 1000 to give us a policy ID. Okay, I'm giving us 10. Authentication, what method you want to use? I want to use pre-shared key. You also have another option called PKE, Public Key Infrastructure. For that, you need to configure a certification authority. That is too much for an enterprises and service provider people. Certification authority, service provider, security guys should learn. That is nothing but a centralized body which will provide certificate, a digitally signed PKI, using which site 1 will trust site 2, site A will trust site B. But here, in our case, we are doing pre-shared key authentication, where I need to provide the password on either side. That's the authentication type, but I have not defined the password. That will be done outside. Now, encryption, you have multiple options like DES, which is 56-bit. 3 days is 3 times of 56-bit, and AES is 128-bit. You can use any one of this. My policy is to use 3 days. This need to match on the other side also on router 2. Next, for hashing, I have MD5 and SHA. In some operating systems, you will have more flavors of SHA. In this operating system, I have only 2. I would like to use MD5 as my hashing algorithm. See, again, it's your wish. If you use on one side this, you need to use on the other side only, then they will form association. Phase 1 association. Next is to provide integrity, you need to use Diffie-Hellman group. And you have various groups, depending on what number you choose, the size of the bit, that algorithm bit, which will provide integrity will vary. The default is 2, if you don't mention. I want to say 5. Diffie-Hellman group 5. Again, this has to match on the other side. The other things are optional, like lifetime and all optional. The default lifetime is going to be 24 hours. Every 24 hours, the rekeying will happen. I'm not changing the lifetime. I'll show you what is default next. Still, the phase 1 is not over. Why? We have said we want to use pre-shared key, but we have not given the key. For that, this is the command: crypto key, crypto IPSec key, and then give any password that you want to give. I would like to give AGNFA, not AG, IGNFA. I don't know, this is one of the department in India. So someone gifted me a wallet where it is written IGNFA as a password. And to whom you want to form neighbor, that address you need to specify. 52, it is only the tunnel destination you should give, not the traffic destination. Tunnel we are forming between R1's G1/0, R2's G1/0. Done. So same password, same combination. You need to paste it on the other side. So I'm going to copy and paste. Show run section crypto. This is what we configured. I'm going to copy this. Only the address will vary. You see, for your understanding what I'm going to do, I'm going to change the policy name. Sorry, policy number. Address is going to be 13001. And this policy, I'm just going to put 100. Just to tell you that the policy is locally significant. The other things must match. This is going on router 2. Okay, so we already know that this address is pinging because we got OSPF. In the real world, ISP will provide us the reachability. Fine. For phase 1 negotiation, there is no problem. Both side, the policies are matching, the encryption algorithm is matching. Hashing. Show crypto ISA KMP policy. You see, the lifetime by default is 86400 seconds. Yeah, the default is 24 86400. Diffie-Hellman we used pre-shared key message digest means triple this. All right, now let's move on to phase 2. Let me do it on R2 itself, and then I'll copy and paste it on R1. Crypto, sorry, not here. Crypto IPSec. There we saw crypto ISec MP as the command. For phase 2, it should be IPSec. Crypto IPSec transform set. See the name transform. Meaning I'm going to take the data and transform it so that no one will understand it. For transforming, I'm going to have some policy with what I will hash it, without what I will encrypt it. Alright, so for the transform set, let us give a name. I would like to give a name as easy to remember tset. See, everyone will use this tset in the security world as if it is a command. Well, I'm used to this name. It's just a name. You can give any name. It is easy to remember. Why I need to remember? Because I need to call this under the crypto map. That's why I'm giving something which I will remember always. But it is not mandatory to type this name. Most of the people, you will see them typing this name. That's it. Transforms. Now, how you would like to transform? You see, if you want to only encrypt it, then you can go with this, or this, or this. Or you want to do only hashing, you can go with this. See, HMAC means what? Hash. Hash, HMAC. Hashing. If you want to do both, you can do both. See, I want to hash it with SHA, and then I want to encrypt with DES. This and the phase 1 combination doesn't need to match. If you match also, no problem, but not necessary. In phase 1, for hashing, we used MD5, I remember. Did I say MD5? I think so. Yeah, MD5. Here I'm using for transformation of data SHA. There we used triple DES as encryption. Here we are using ES, DES as encryption. Damn. See, this is default mode called transport mode. If you want to change into tunnel mode, you need to say mode and you need to say tunnel. But we are not going, sorry, the default mode is tunnel mode. I don't know why I'm messing with the words. The default mode is tunnel mode. If you want to change it to transport mode, you need to come here and say transport. I'm not going to say any mode, which is going to be what? Tunnel mode. I'll simply escape from here. And this is going to be the same line pasted without any alteration. Name can be changed if you want. Okay, let me change the name. The name is locally significant. I'm going to say, instead of tea set, I'm going to say coffee set. I'll paste this on R1. Remember, transform set is called as coffee set in R1. All right. Now, phase 2, partially it is over. The remaining part of phase 2 is defining which traffic will get this encryption service and then putting all together in a folder called crypto map and applying to the interface. That is what the last step we need to do. See, we want to encrypt any traffic going between the R1's inside and R2's inside. R1's inside network we have simulated using loopback interface 10.12.1. R2's inside is 10.12.2. In either side, the first two octet is same. So what I can do is I can write one common access list. Access list 101 permit IP going from 10.12.0.0 0.0.255.255 going to 10.12.same 0.0.255.2. If you write like this, you don't need to write different access list on either side. It's common. Both the side two octets are same. I'm going to copy this and paste it on R2. Right. So access list is going to be used in the crypto map to say only those traffic that matches this source and this destination should get encrypted. What is next? Next is putting all together and applying it on the interface. You cannot put everything on the interface directly. So you need a map, crypto map. Give any name for this. I usually give C map as a name because it's easy to remember because I need to call this under the interface. Crypto map. You may have many maps for the same interface. You may be having multiple site-to-site VPN. So even though you give CMAP as a name, you also need to give an ID. Why? You can have multiple CMAPs. CMAP 1, CMAP 2, like that. CMAP 1. And you just call that CMAP to the interface, all CMAP 1 combination, CMAP 2 combination, everything will be applied. That's the idea. That's why you need sequence number. Next is we are going to use ISA CMAP 1, IPSec, ISA KMP. That's what we are doing side to side. Now, first thing what I want to do is I want to say which traffic to get in. Match address. The access list number. The access list number that I have used is 10. So the crypto map will try to match with this access list. Sorry, the traffic with against this access list. The traffic that will enter into that G1/0. This is where we are going to apply this crypto map later. So when a traffic enters or leaves G1/0, it will match with this 101 access list. If it matches, it is going to transform the data using the transform set which we created called T set. All right, next is, these are the two important things. Set, match. The other things are not very important. Set peer is an optional one. It's okay. I'm going to give peer. Peer is 13001. Set peer is not an optional one. Sorry, it's mandatory one. So for every crypto map, you will have different peer. This is crypto map 1. Let's continue. So now we have come to the final stage. What is that? Applying to the interface. But before that, let us finish this crypto map configuration on R1. Going to R1. Okay, it's already done. Now crypto map. There I gave C map. Here I can give any name. I'm going to give A map. There I gave 1. Here I can give 10 also. Just to show you that it can be different. IPSec MP. Right, and next is access list, match address 101, set transform set, coffee set. Give coffee set here. And then we are going to say set peer. Peer is the public IP address on the remote side, 52.0.0. 52.0.0.2. Next. It's time to apply this on the interface. See, I'm going to copy this A map and I'll go under the interface G1/0. Crypto map E map. That's it. Same thing, I have to do it on the other side. Crypto map. The name of the crypto map is C map. Now you will see IPSec can be on. Fine. But unless you generate some traffic, show crypto IPSec MP SA will not come up. The tunnel won't come up unless you kickstart, initiate some traffic. But the problem is there is no route to reach. There is no route to reach 10.12.1. You see, there is no 10.12.1 in the routing table. Why? Because we are not running routing protocol for this network. So you need to somehow make the traffic to go out of the router. Only then, out of which interface? Out of 1/0 interface. Only then the traffic will get matched with the routing table. Sorry, the traffic will match with the access list and the service will be provided. So you need to write a static route. Simply, this is namesake, you are going to write IP route. If you want to go to 10.12.0.0 network, go to 52.0.0.1. Even if it is not 1, it is okay. But I'm giving 1 because I have put /30. I cannot put any other number like 3 or 4. Subnetting won't support. This, I'm just pushing the packet out on G1/0 so that the encryption will happen. I'm not expecting R5 to root this packet. Can R5 root the packet? No. I'll show you. On R5 you don't have a root. Show IP route for 10.12.1.0 network. There is no route in the routing table. There is no route. It cannot route the packet. R5, R4, R3 don't have the root because there is no OSPF running on that interface of R2 and R1. Okay, likewise, I'm going to write another similar static route on R1. Just to push the traffic so that the VPN will get kickstarted. Alright, now if I'll try ping, you see what happens. Even though R3, R4, R5 do not know 10.12.2.1, even though R5, R3, R4 do not know this source and this destination that I'm going, even though they don't know, the packet will get routed. I'll use, see, I lost one of the packet because it took some time for the ARP and VPN to come up. You know very well these routers don't have any idea about this source or this destination, but you already got the ping. It is because the middle routers, they don't route the packet based on the original source and destination. They only route the packet based on 13.0.0.1 and 52.0.0.1. This original source and destination is totally encrypted. That I'll show you in a few minutes by sniffing packet. If I type now show crypto IPSec MPSA, earlier there was no VPN tunnel. Now you can see tunnel source is 13.0.0.1, tunnel destination is this, and it is active. Likewise, on the other router, R2, show crypto IPSec MPSA, you will see this. Not only that, if I type show crypto IPSec Security Association, you can see 4 packets got encrypted and decrypted. Let us ping one more time from the other side. Now another 5 packets. So 4 plus 5, 9 should come. You see 9 packet encrypted and decrypted. And I was telling you the default is tunnel mode. You see, transformation happened using this algorithm, and the mode is tunnel mode. And if you go up, you will see for which source and destination this tunnel is working. Tunnel is working for any traffic coming from this source and this network as the destination. See, the local is source, the remote is destination. The CMAP is pointed towards the remote. Please ask me a question if you have.